This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, okgrow.com, and spacedojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. All right, welcome back, Crater fans. So last talk of the day is actually the first talk for Ian. It's like 5 a.m. where he is. He's up super early. But we have Ian, is it Serlin? Is that how you say your last name?
That is correct.
Ooh, I got one right. So Ian runs useful.io, which is a consulting shop. And they build Meteor apps. And I think you're going to be talking to us about building a DDP API, right? For one of your clients?
Totally. Sort of.
Awesome. All right. Well, I'll leave it to you.
Sweet. So I'm excited to be here. I've spent the last year or so going around different places in the world and talking about Meteor to different communities. And it's fun to do one online with such an awesome group of people. So thank you, Josh, for having me on. So yes, I am. Yeah, thumbs up. Cool. Oh, that's crazy. Screen share. Let me I'll just go to here. So yeah, here am I. My name is Ian. I started Useful.io. And we are a team of 5 people who've been building Meteor apps for 3 years now. We're one of the original Meteor partners. You can check us out at useful.io. But basically, now that we have the caveat of it being 5 a.m. where I am in Taipei out of the way, so apologies in advance if something doesn't make enough sense. I'm hoping that this talk will be both fun and sort of interesting. And my goal is to get you excited about building more APIs. I don't know if you can see my face on the screen or not. I don't know what Josh is doing behind the scenes, but we will just continue from there. So, why do I care about APIs? Basically, we, over a number of different projects, had a lot of different messaging needs around email and all that kind of stuff. And turning that into a reusable API that we could basically use in all of our applications took some engineering. And it should have been a lot easier than it was. But I just want to switch over and show you a little bit of what Hail can do at this point. So I'm going to start the Hail server for push notifications. I thought it would start faster than that. Okay, so I'm gonna go to, just localhost here. And Josh, can you put up my screen too? And I'm just gonna log in as desktop Ian Serlin. So this is just like a basic application, but it has Hail installed. And Hail is based all around conversations and stuff like that. So Josh, can you give me a message to type to myself?
Hi from CraterConf.
Hi from CraterConf. Okay. I'm going to hold my phone up to the screen. Hopefully you can see that. So send a message. And you can see that. Okay, so let's move to the next thing. I'm going to start the email example. And when this gets going, should be quick. Meteor build time's supposed to get better and better. Dead, silence, blackness, and then an application. Okay, cool. Okay, so email example, I'm just gonna sign in as me. And this is just I'm not a CSS person, but do like UX. So it's just a horrible looking demo application. So give me another piece of text to write.
Where in the world is Sam Hatum?
Where in the world is Sam? Is it Hatum or Hatum?
Yeah, Hatum.
Okay, so we sent that, and it's I am basically another user that has logged in and watched the sales or the support channel here. So in a minute, that should probably come through into my email. Anyway, so why do we even care? Basically, the reason I care is because if I show you what it takes to actually do, like, get that sent as, like, let's take the push notification example. Most of this is just your basic like template Blaze jazz. And then what's happening on the Meteor server side is it's creating conversations in Hail. Conversation is just a group of messages and a group of people that care about them. And we've got push enabled for it and a template. Then, maybe I should have, can we see that real quick? Okay, it's probably long enough for it to be clear. And then what's happening is every time someone sends a message, it's doing this conversation.send, but since we've set it up for push, and Hail knows how to register devices when you have the Hail package installed, it can send push notifications to, the other recipients in the conversation without you having to do, anything else. The same deal with email. We have the same, just sending the message in the conversation. And then in the conversations, we're just setting the initial conversations to have emails with subject templates and then text templates and, all that sort of jazz. So that maybe doesn't sell you on Hail. I mean, here's our support message from Useful Ian to Dr. Mario, where in the world is Sam Hatum? So this was put through our template, and that's the content. Okay, so sending emails, sending push notifications, like not that amazing, I guess. Like we've all probably done this at some point in the past. Let me just delete this promotional text real quick while I'm talking. So why is that cool? Well, like the whole point of Meteor was to have a really awesome API for building applications quickly. And that was, hopefully you thought, only a few lines of code to do something pretty cool. And like, that's really the power of APIs. Gosh, right? We all know APIs are all about abstraction. So the problem I have is that I'm always dealing with these old school APIs. And, if you are looking at, if you're just like sending an email through Mandrill or something like that, and you're just like, fire and forget type thing, it's not that big a deal. But you can, if you use the tools that Meteor gives you to build APIs like themselves over, yes, they're over WebSockets, but, specifically APIs designed for Meteor applications, you can get a lot more bang for your buck. You can get a lot more mileage because the Meteor people have already put a lot of thought into how to get data back and forth with the whole subscriptions and methods and all that kind of stuff over web. So there's a whole bunch of like higher level set of functionality you can do with minimal amount of code that will help you to build more interesting, more complex things quicker. So why? Yeah. So then one other question is, okay, great. If I'm going to build an app, or if I'm going to build an API for Meteor applications, that means only Meteor applications can use it. Well, I mean, there's enough of us building Meteor applications that we have this online conference now. I think the last time I heard Kadir, which is the performance monitor for Meteor, had like 5,000 installs. Like there are people out there building Meteor applications, and with the push in terms of marketing, I don't think that's going, from the MDG side, I don't think that's going to change or go away. If you're not coming from, a Meteor background and you're watching this talk, thank you for sticking around. What might still be interesting to you is the fact that all of this is happening over WebSockets. So you could easily build your own sort of transport paradigm over. But if you are using Meteor, you don't have to worry about that at all. So for the first time, out of anybody today, I'm going to zoom to the next dot. We're going to talk about what does a Meteor API look like. So there's a couple different concerns, right? In normal Meteor applications, you just have your user ID, but now we're talking about a connection between a client that's outside, like a client that's separate from your server. So it's not the same as like just Meteor accounts. And Josh, can you skip to my, like, I want to use my hands for a second. So it's a heads up, probably. Yep. My hands, you can see that. Okay, cool. All right. So if you're going to have a Meteor API, if you're going to host a Meteor API, if you're going to run a Meteor API, you have your Meteor API server on one side. And that Meteor API server might serve like an admin user interface that lets people register to use your API, generate their keys, all that kind of stuff. And then the other two things that you're going to have to deal with are the customer apps that are going to be talking to your API. And you need to deal with that in two places. One, on the server side. And the server side that's connecting to your API is traditionally more trusted code. So maybe that has more privileges. You can do more things in your API. And then you have the client side. The client side of your customer application that's also going to be connecting to your DDP server. And so how do you do this identification between these three pieces? Well, you always have API keys. And basically what this looks like is you give one pattern is you can give a public and a private key to each customer or client, Meteor application that's going to be connecting to your API. Public key goes to the browser, private key goes to the server. And now you have a secure way to have privileged access to your API, but also allow all of your clients to connect to your API, all of the web browser and Cordova clients to connect to your API server too. And that's important because when we saw a couple bubbles ago, one of the things that your API can offer is the ability to offload work and offload processing, especially things that have to do with like things that are expensive, like subscriptions, etc., to your API server, so that person doesn't have to deal with it. They don't have to worry about scaling their Meteor application in that way to support that use case. They can just rely on you are solving one use case for them, and they can build on top of that, just like anything else, just like account space, etc. So you want to have a connection from each of them, the client and the server, to your API server. But you probably also want to have the ability to identify each individual client that's connecting to your API. So each individual client of like that application, your customer's application that's connecting to you. So you can do things for that on behalf of that client, like publish only the whatever that belong to that particular client of that particular application that's using your API. Hopefully that's sort of pretty clear. The way that works is basically a client requests to register. The way it can work is the client will request to register with its server with your API. Now, because the server is privileged, it can register with your API and return back a personal key for your API for that one particular client. And yes, this can all be based off user ID. And Josh, jump in if I'm not making any sense here. But then, because you're securely requesting a personal key for that client of that customer application, then the combination of that public key and that private key is enough to reasonably securely identify that particular user of that customer application to your API. So now you can do things almost like that person is literally logging into your API. So with that sort of said, the thing that I want to introduce, oh man, I spoiled myself down here. I forgot. Okay, so what I want to do is show you this. With the work that we did with Hail, building Meteor APIs, and the fact that I've been talking to people about building Meteor APIs for a good little while now, these patterns can be codified into packages that you can use. And that is exactly what we've done. So as of now, you are the first people to see this. If you go to github.com useful.io/API-base, you'll see the repo that has two packages inside of here. One is the API server, and one's the API client-based package. Okay, so what does the server-based package do? It actually, yeah. So, I mean, the API server-based package is what you want to install into your Meteor app that you're going to expose an API from, and it handles all the things like identification and all that kind of stuff. And this little bubble here where I said keeping state, so that state is kept on the WebSocket connection. And, you know, I'm feeling like I'm just going to start the example app here and talk through this because maybe it will become crystallized in that. So I'm doing two things. I'm running, I took the basic Meteor to-dos example and turned it into a to-do app that's backed by an API that serves to-dos. So what I'm doing right now is hopefully this text is big enough, starting a to-do server, which is the API server, and then I'm starting an example client app. Okay, cool. So let me first show you the server. Let's refresh this. Okay, so here's what I'm talking about. We've got a list of apps that have been registered with our system, and each of them has a public and private key pair. Okay, so what I've done then, in the client application, I've taken that public and private key pair and put it in the config file. Then this is your basic exact same Meteor to-dos example, but everywhere where you would normally see just tasks, we're doing the to-do API.tasks. And when you would see Meteor subscribe, we're doing the to-do API.subscribe. And when we would be doing Meteor call, we're doing to-do API.call to add the task or set the private, etc. That to-do API is coming from a package that we've created as an example called to-do API. That is in this packages folder under to-do API. It's using the useful API client, and then all it's done is this. So what the useful API client does is makes it easy to connect and identify and authenticate yourself with API server that's based on the useful Meteor or the useful API server. So what we're doing is we're setting the URL for our API. We're giving our API a name. That's important for basically caching that private or that personal key that we were talking about. We're loading the config from we're loading the config from the settings file that was here. And then we're calling configure. And because to-do API is a new instance of API, which is exposed by the base package, it's going to handle connecting to the server, identifying all that kind of stuff. On the server, we're basically doing the exact same thing. And then because what we want to do is, from what the functionality that we want to do in our to-do, exposed in our to-do API is to let people manipulate tasks. We are exposing a collection called tasks with the connection set to the same connection to our API server. Okay, so if you followed me this far, this is hopefully starting to make some sense. So we've used the API client package to basically give us abstract away a bunch of mumbo jumbo monkey business that we needed to do in order to basically manage the connections to our API server. And that let us just focus on what we really want to expose via our API, which is this tasks. And then whatever other method calls and stuff like that we want to expose on our server. So if we look at to-do server, this is the API that the to-do server exposes. And it's basically the exact same thing that was in the Meteor to-dos example, except I've just replaced Meteor with API. And this to-do server is using the useful API server package as a base. And because of that, you can get away with doing just API publish and knowing that it's going to be authenticated, exposing methods and knowing those methods are going to be authenticated. One of the maybe more interesting things is this API intercept collection stuff, but I'll get back to that in a second. So without taking a breath, I guess. So here is that API client to-do client running. That was this one here. And let's see. Creator Conf give talk at Creator Conf. So, This really shouldn't be like that surprising. I will also the email address josh@serlin.com. Right, so I don't know. Could you see that switch? One, they're two different clients. There we go. So, like in itself, not that amazing, but the point of this entire pair of packages is to make it so you can do more amazing things. Okay, so too many tabs. The publications. The publications are secure here, and the methods are secure here when you're adding them via API, because if I show you what's actually happening, when you call API publish, it will check if there's an identity associated with this connection, and if there's not, it'll throw an API not authorized. The methods are the same deal, and actually the collection intercepts are the same deal too. Again, I'll get back to that in a second. So it's basically wrapping and saving your connection. So where do those identities come from? When the client connects, it calls a method on your API called identify client, which ends up here. It looks up the public key, and if it can't find an app associated with that public key, it's going to throw an exception. If the client has a personal key, then it will look up the client for you. Otherwise, there's no client, and it will create a new identity object for you and store it on the connection. This connection is the key to keeping this state, because the connection object is available to you in all of your method calls, bodies, in all of your publication bodies. So basically anywhere that an API client is going to touch your API server, the connection object will be available to you. And now the identity object will be available to you too. In a similar way, when a server that's connecting to your API boots up, it will call identify server underneath the hood, passing in the private key. We'll look up the app for the private key. If there's no app, throw an unauthorized exception. Otherwise, we store a new identity object on the connection so that you can use it anywhere else. Where might you want to use it? Well, in the to-do server, let me just close that one. In the to-do server, we're using the connection identity app ID that was tacked on there for us to make sure that we're only returning tasks for that particular app. And we're using the connection user ID to look up tasks that were only for that user. Now this user ID, this is the user ID of the the user ID of the user of the application who is connecting to your API. It's not a user ID of like a Meteor user inside of your own Meteor application that is the API. This is the user ID from the user that is registered in your in the application that's connecting to your API, just to reiterate. And why
So the
that's
API
important
client, is that the API client then?
is that the API client. So we've
Yeah,
got,
the user ID is coming from the API client. Is that what you
yes.
mean?
So,
Okay.
yes. Yeah. Thank you. I'm tripping over some words here. Yeah, definitely I do better with like back and forth. So clarification is good. The reason that's important is because whoever is consuming these tasks presumably cares about the user IDs of their own users, not any other user IDs. And so because it's available to you, you can effectively do things with it. Same here where we're specifying, like, let's see, adding, what's a more interesting one? So delete task, right? Normally, normally this is pretty straightforward, but because you have the identity connection again there, you can make sure that you're only deleting tasks that are associated with this connections application, and you can get the user ID again and check ownership and all that kind of stuff if you want to. Okay, so if all that is sort of like fundamental, I guess, maybe. The intercept collection thing should be pretty straightforward too. And what this is doing is hilariously under the hood. Here, it will rewrite the Meteor method that's automatically generated for you when you declare a collection. So normally, like when you declare a collection, like new Mongo collection creates something like that. Under the hood, Meteor is creating methods called creates, insert, etc., and like putting in its default function. That's great. That default function basically uses allow and deny to do things, but allow and deny is not really going to help you out here. So there's a mechanism to basically substitute whatever method you want to use for the method that Meteor is originally creating for you. And if you do that, then it will also check the API identity and throw an unauthorized exception back to the client if it tries to connect before it identifies, or if someone's trying to manipulate your API. So then the question becomes, okay, why would you want to do that? Well, basically, this is a bad example just to illustrate the fact that you can do it. Okay, so let me just do it and show you, and then maybe we can talk about why that might be interesting. So if we try to insert to tasks, we should get this error message back. And just kill this one. So I'm going to do API.tasks.insert muffins are delicious when they are blueberry. I feel like you really get to know people when you see what kind of test data they put in. Okay, so we got this error back. Nice try, but you must use the provided add task method. So that was all just to demonstrate that, like, when you call intercept and it will work, you will get what you this will run. Anyway, the reason you might care is because as cool as, abstract API names are, and like models, or even even things like GraphQL, there is a place for, directly using collections. So like collections.insert and update and remove. And this just facilitates allowing, literally giving a third-party application direct collection manipulation access to collections that you're hosting inside your own API server from their client code, which is sort of kind of cool, I think. Okay, so yeah, so those are the useful API client and the useful API server, and boom to the next one. Okay, so the future, we abstracted those two packages out of dealing with what we wanted the API for Hail to be like, and so that we could make potentially, and other people could make more Meteor specific APIs in the future. If people think that it's interesting, like if you start to use it or something like that, and we actually have like these other Meteor APIs that we can build awesome applications on top of more quickly, I don't see that changing when reactive, or like when GraphQL and all that kind of stuff comes out. I mean, it's the GraphQL is like the gorilla in our banana tree, our happy banana tree paradise right now. But when GraphQL comes, it's just going to be another mechanism like Meteor methods or like the direct collection access in order to like access the data and go back and forth. So that could be part of the future of Meteor DDP APIs. If you maybe build an API that's incredibly popular, and you need to super duper scale like one part of it because it's all WebSockets, and now you have Phoenix, which basically does WebSockets on crack because it's based on Elixir. You could offload part of that DDP API to Phoenix. And that's like basically writing a DDP client / server for Phoenix, I think would be a lot of fun project. If anybody is interested in doing that, we would be down. Then just to wrap up, basically, we got stuff for you to use. So Hail, if it's at all interesting to you to have an API that you can drop into your Meteor app that does instant message inside of your application, plus syndicates to push notifications, plus syndicates to emails. And the email stuff is two-way, by the way. You can reply and it'll end up back in your conversation. We're doing another round of closed betas next month. And Hail is the system that we already use in our own production applications. It's the same thing. But if you're at all interested, just go to hail.io, enter your email, and you'll be kept up to date on what's going on with that. The useful API packages that we just talked about are right here. We also have a blog. So Useful.io is 5 people. Joshua Ullman writes stuff about technology and also about BDD. He's actually a student of Sam Hatum right now, which is cool. We also have Lucas Jagodzinski, and he is the creator of astronomy. If you haven't heard of astronomy, try Google Meteor astronomy. It's going to be pretty hilarious what you see. But if you go to atmosphere and search for astronomy, you'll actually find what I'm talking about. And he occasionally writes about stuff related to meteor and technology there. We've got Vlad Belan, and he writes stuff that's more about how to work remotely and team dynamics and all that kind of stuff, and how to keep
All right. So I think this is like, for me, this is super exciting because basically you've added authentication around microservices. So this isn't like some of the stuff you were showing. I've actually played with, like you can just make a DDP connection to another Meteor server and request publications or make Meteor calls. And like I've used that stuff, but um, I asked some people if they'd be interested in me writing a microservices article, but the thing that comes up most frequently is like, how do you handle authentication across multiple Meteor servers? And like you essentially just solve that problem, right?
I'm going to cross my fingers and say I hope so. I think so. I'm trying. We're trying because we need to do it for ourselves. And so it seems like a reasonable way to approach it with the API keys and the registrations in this. I mean, if you need to regenerate an API key, you can do that too. I would be very interested to see what other people say and what kind of holes they poke in it after hopefully it's interesting enough to take a look at and review.
Okay. Can you hear me okay now?
Yeah, you're good.
All right. So one of the questions we had early on in the talk is, are you using Rake's push for the phone notification stuff, or are you using something else?
No, we're not.
Okay.
Yeah.
Awesome.
So you don't, the Hail server, no, I don't have anything against that package at all. The Hail server will handle sending out the push notifications for you. So unlike if you're using Rake's push, your server is not going to be having to directly talk to the like APNS or GCM or something like that.
Okay.
Mm-hmm.
All right. So Ian Hilt asked, is it possible to use the API client to connect to APIs not created with the API server? And I think this is what I was talking about before. You can just do this right now with Meteor. I think the thing you get with API server is the authentication token kind of checking and that kind of stuff, right?
Yeah. So the API client basically handles I think maybe the audio and the video are not synced up exactly. And maybe I'm hearing you before I see you finish talking. So I'm just going to try to answer. And if I miss something, just let me know. Okay. So yes, the API client basically does nothing for you besides expose the methods or like the functionality that's available to you on DDP. And then knows how to authenticate itself to an API that's being run by the useful API server. So no, you could tell it to connect to a different Meteor server, but you wouldn't get any benefit out of doing that unless that server was based on and exposing an API using the methods provided by the useful API server package.
All right. So the next question comes from Evaldis, and I'll say I'm done when I'm done. Do you use some kind of connection pools for your API to avoid using too many resources? End question.
No. There's no connection pooling going on in the useful API server package. It is basically the vanilla functionality that you get with Meteor's ability to handle WebSocket connections out of the box, and all the reconnects and stuff. Goodness, what they will do both of those packages, if there's a connection dropped, they will re-identify themselves on the new connection automatically for you. But that, I mean, that's going towards optimizing your whole application. And I would love to see something around that that we could integrate into the package for
Well,
sure.
in reality, you're just hosting a Meteor server setup, right? So you could just scale up like you would a normal Meteor server, and add a second process that's hitting the same database. And as long as you have sticky sessions and the load balancer in front of it, like we saw in a previous talk, you could scale it that way, right? Done.
Yeah, totally. And if you wanted to get even fancier, you could split different parts of your API into different servers, and then have two API clients that are connecting to two different API servers that just share the same database or something like that. Yeah, basically any way you can slice and dice, scaling up a Meteor server, then you could do. It's just a Meteor server, and if you needed to get more fancier than that, um, then you probably want to switch to something that you're just handling the raw WebSocket connections yourself. I mean, there's like seven DDP message types, or 11 or something like that, and it's not terribly complicated. But what you get awesomely from Meteor is everything to do with live subscriptions in the Mongo op log and things like that. End answer.
All right, good answer.
We won't say whether it's a good answer or a bad answer.
So Ryan had a question: is Hail tied into Blaze, or can you use it with anything? Your example code appeared to have template stuff embedded in the API call, but I realized I might have misread it. And
Hail has nothing to do with Blaze. It's just exposing some functions. It's basically what you saw with the to-dos. You have Hail deals with conversations, messages, and people at the base level. Conversations are groups of messages. Messages are written by people or your app, your system. And those collections are exposed along with some like sugar, syntactical sugar, to your client. So you could be using that within React. You could be using it within Angular or Blaze, anything. It's just my horrible API or my horrible demo UI was written in Blaze.
all right, fair enough. All right, Ryan, you've got the top question right now, but it's maybe not super clear to me, so we'll come back to it. Maybe you could edit it. Evaldis wants to know: are you aware of Meteor Hacks cluster, and how are you scaling your API? And I would say, before you answer, for me, Meteor Hacks cluster can kind of take care of that problem of like handling discovery and the connection strings between your API servers using Mongo database. So I think that's where that kind of gets interesting to me. Done.
I am aware of Meteor Hacks cluster, and it's a really good question that I don't have a good answer for at the moment, because with our production applications that are using Hail, we're scaling them the normal way. And basically those businesses are scaling up themselves. So there's not a whole ton of pressure on it at the moment. But one of the things we need for something that's like a closed beta, or there's just not a lot of people using it, is some way to do the load testing to know like how is it going to break, and how are we going to scale it, and all that kind of stuff. And like we're working on those load testing tools too. and those will probably be released as well. I know there's some out there that are based on Java, but when you think about it, really you just need to make a bunch of WebSocket connections and send a bunch of DDP messages to your Meteor server to like tell it to do a bunch of stuff, and basically do that enough times in parallel. Yeah, exactly. You need to do that in parallel. And so, I mean, it's not a terribly complicated thing to imagine how you would do it. But making a nice tool to do that is something that, you know, we're also working on. And when we're done, we will release it too. And then I'll have a better answer for like, how are we going to scale it? Because I'd be able to tell, like, know what the differences were going to be at different scales and what would help the most. And like, I don't know everything either, so
none of us do.
I'm open. I'm open to feedback.
Yeah.
Maybe I should have said Galaxy and been done with it. No.
I mean, it's an option, right?
Yeah.
All right. Next question from Ryan. So he's curious if having two DDP sessions open at the same time might affect mobile resource usage. Does it cause more memory, more battery drain? He knows how heavy one Meteor app can be on mobile. How much does it adding a connection to a second Meteor server add? Do you have any thoughts there? Done.
I just think that's a really good question that I again have no answer to. I would imagine, I mean, there's going to be some cost because it's maintaining or it's creating more network traffic. I don't know. I would guess that
it would probably depend on how much traffic you're really sending, right?
And I mean, in that case, it doesn't really matter what connection you're using, but in just terms of like, what is the extra load that the maintenance of that one WebSocket or that second WebSocket connection creates? I don't know. I'm writing down this question because it's a really interesting one.
Yeah, I've got to imagine that it's minimal, right? Like we're talking about TCP overhead, we're talking about some packets. Like I can't imagine like tracking that maybe uses a little more memory, but I mean, I would think it's almost incremental. I've got an app. We could try this in at least on a desktop, so you can use that. Have you seen Paul Irish's client side memory tracker?
There's a bunch of new tools that came out for like doing stuff inside of Meteor applications that I haven't used. I'm ready for a demo.
Yeah, I'll have to set up an experiment, but this is actually just a general JavaScript thing that you can use, and it just tells you like how much memory is being consumed. And he's got a cool little graph for it. I saw it in a React talk from React Conf last year, and the experiment I guess would just be to just have one DDP connection and then make a second one and see if that increases the memory load, and that would probably answer the question a little bit.
Yeah, what was the tool called? Paul Irish's something?
I think it's just like memory stats for JavaScript.
Okay. Yeah, I'm with you in terms of like that intuition, but I don't want to shoot myself in the foot by saying, yeah, no, it's going to be fine. And then like, I don't know, man, like the Android web view maybe like blows up when you have more than one WebSocket connection. I'm not sure.
I will say this. I think that there is a limit, and I think there's a hard limit within the WebSocket standard somewhere itself, or some way the browsers have implemented it. I've seen both Chrome and mobile Safari, regular Chrome and mobile Safari crash when you push too many DDP messages through at one time. So, I mean, there's probably like all kinds of weirdness in WebSocket itself still.
It could be, yeah. I guess you could always like, and thank you, Elijah, for posting that link for me. Also, yeah, though, to what Ryan was saying about like not wanting to use dev shops not wanting to use WebSockets because it's not a good use of mobile resources. I mean, you can definitely with Meteor turn off like the actual WebSocket thing and just go over like HTTP long polling and all that kind of stuff. I don't know if that's going to be better or worse, but that's sort of all handled for you in sock.js. So that's cool / one option that doesn't kill your ability to build something an API quickly and something you use. If I use Meteor, I always use sockets.
Yeah, but you don't have to.
Yeah, but if this, I mean, if the socket degrades, the sock.js under the hood will downgrade to doing long polling for you automatically.
We should test this. I challenge you, Ryan, to write a test using the link right above your comment there. All right. PDI, please do investigate for the rest of us. So Pete asked, how are you handling stripping signatures and footers out of email responses, or are you?
I don't. I leave it up to you. You can definitely process the emails if you want to.
So the answer there is you're super flexible, and that made sense for the business.
It's definitely not an easy question to answer. You know what, we have figured it out. Well, I don't want to say figure it out. One of our applications does do that, and it would make sense for us to like release that code too. So I'm making a note to do that as well. I can't say it's foolproof, but it works good enough.
Pete said he has a click here to reply link within the email, and that gives him an anchor to look at. So interesting. All right. Last question as we wrap up day 2 here. Rolf wanted to know, so I'm assuming he means API server and API client package work with 1.3 yet or not yet tested? Probably yes, who knows?
I haven't tested it yet. And actually, it's set to like 1.2.1, but honestly, it could probably work with the Meteor 1.0 app. I just haven't tried. And if people I had no idea how interested people or not would be in this, but if there's people that are interested in it, then I'm like, the team is willing to spend more time to make it more useful.
He said, yes, he's interested because those build times are terrible. No, I'm just kidding. He didn't say terrible. But they are better. They are better with 1.3. I will say that. Better.
Yeah, cool.
All right.
I haven't tested it.
All right. Yeah, he's going to try it for us so he can report back with a tweet.
I like it.
All right. So I guess that's it. I want to say thank you to Ian for giving this talk here today. I think it's interesting. Really appreciate it.
It was a pleasure. I will answer. Oh, so many thank yous. Daniel and Dave and another Ian, and Elijah and Rolf and Ryan and Masej and Robert and Maurice. Thank you guys all for coming. Thank you, Joshua, for having me. I love what you do in this community, whether it's stirring up trouble or disseminating knowledge. It's always awesome. So if there are any more questions, you can contact me directly. My email address was up there before. But any complaints, please.
I don't think you're in the Slack chat room, but we have a Slack chat room for the conference as well. I'll make sure I get you in there.
Okay, cool.
All right.
Any complaints,
thanks, guys.
we'll see you tomorrow. Yeah.
All right. Bye. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com, or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.